Okay, carnot cycle. Carnot theorems just come from Carnot cycle. Carnot cycle is a perfect cycle which operates between two given reservoirs. The cycle consists of two isothermal processes and two adiabatic processes. Here is a Carnot cycle. In TS diagram is square. From state 1 to state 2, state 2 to state 3, from state 3 to state 4, from state 4 to state 1. Here is just a square. Very simple. Carnot cycle consists of two isothermal processes and two adiabatic processes. 1 to 2 is temperature is constant. 2 to 3 adiabatic process, no heat transfer. 3 to 4 is the temperature is constant. 4 to 1 is adiabatic process. So this cycle is very, very special. Why Carnot construct this cycle? Why he constructed this cycle? So we give some analyze. Why Carnot select two isothermal process, two adiabatic processes? Okay, let's think about that. Carnot certainly hope he could construct a reversible process. He think when the system and the reservoir the temperature is same, the heat transfer process is irreversible. Same temperature isothermal process is reversible process. So firstly, he construct a isothermal process. He think between the system, the piston, and the reservoir, the temperature firstly is the temperature is same, in which heat is transferred from the high temperature reservoir to the piston. Because the temperature is same, so the process is reversible. From the high temperature reservoir into the machine and do some work for the people. He think in his mind the gas expansion some extent, but in the gas the temperature is still high, same as the high temperature reservoir. In this case, you cannot let the piston connect with the low temperature reservoir, so he hope the temperature decrease. Certainly, in this process is a adiabatic process. Let the piston continuous expansion. In this case, the piston do some work, is still some work provide, but the temperature decrease until temperature T2. In this case, the third, let the piston undergoes the third process. In this process, he lets the piston connect with the cold temperature reservoir. Because the temperature is same, he very slow compress. The heat energy goes out from the piston into the low temperature reservoir. So in which the heat is transferred to the low temperature reservoir. Only heat transfer. Outside give some work to the engine. Because the temperature is same, so the process is reversible. Finally, the piston goes down to some extent, but the temperature is still T2, cannot connect with the T1, the reservoir, high temperature reservoir. So he hoped the temperature increase. So he let the piston insulation, continuous compress it, adiabatic compress it. In this case, in the piston, the temperature increase. So in this case, need some work from the outside. So in this process, is still reversible. In this process, the temperature of the working fluid increase from the low temperature to the high temperature. So come back to state 1. So Carnot cycle includes 2 adiabatic processes and 2 isothermal processes. So the Carnot cycle, together with here, 2 isothermal processes, 2 adiabatic processes. Because these 4 processes just come from his head, it's not a real process. So we can think the process is reversible. In this case, we calculate the efficiency, certainly is highest. TS or PV diagram, we can draw the Carnot cycle, PV diagram, TS diagram like this, PV diagram like this. The efficiency is W over Q1. The first equation is the definition. Because W is our benefit, Q1 is our cost. From the first law, we can obtain 1 minus T2 over T1. Here is because W is Q1 minus Q2 from the first law. The third equation is 1 minus T2 over T1. Here is in that day is very difficult to obtain. But from the ideal gas equation, we easily obtain this equation. Conclusions, we have learned the Carnot theorems. From this section, we know the efficiency of Carnot cycle is only related to the temperature of reservoirs, without relationship with working fluid and engine construction. We increase TH and decrease TL. Certainly, the efficiency of Carnot engine increased. However, TH cannot become infinite. TL cannot reach 0. So, Carnot engine, the efficiency always smaller than 100%. When TH equals TL, means single reservoir. In this case, eta C is 0. Just tell us single reservoir engine cannot be made. Here's conclusions. Thank you.